let's go ahead and check your work on this problem. So first we need to figure out her monthly payment so we can figure out how much she totally pays over the 8 years that she's paying back her loan. So if I just plug things into my formula, my monthly payment is equal to my principal, which is $1,800, times my rate as a decimal, so 0.043 over 12, times, it says 1 plus my rate again over 12, oops, I forgot my 3 there, to the 12 times my number, my time, which is in years, so that's times 8, all over 1 plus my rate over 12, to the, again, my 12 times time, so 12 times 8, and then minus 1. Again, if I'm plugging this into my calculator, I'm going to make sure to put my entire numerator in parentheses, my entire denominator. If you're going to get some sort of error on your calculator, it's something to do with your parentheses more than likely. So make sure that if you have a starting parentheses, you also have a closing parentheses. So when you plug that into your calculator for your monthly payments, you should have gotten $221.93. Again, that's your monthly payments. So to find how much totally she pays, her total payments, we got to figure out, well, she's paying this monthly payment, she's doing it for 8 years. Well, I know that 8 years times 12 is going to give me 96 months. Again, I have to convert it into months because my payment happens, it's called our monthly payment formula, so it's per month. So I got to take this number times 96 to figure out how much she totally pays, and that's going to give me $21,305.28. And this is how much she totally paid over 8 years. However, this problem asks for the interest. So how much did she pay in addition to what she just borrowed? So we have to take how much she totally paid to find our interest. So that's at $21,305.28 minus $18,000 that she borrowed. And that's going to give me for interest $3,305.28. So again, for the convenience of getting a loan, the bank is going to collect $3,305.28. So hopefully you got the same answer as me. Sometimes we're going to see questions that look like this one here. Let's just read through it and we'll talk about how it's different. It says, Claude wants to borrow $25,000 to purchase a car. After looking at his monthly budget, he realizes that he can afford to pay per month, all he can afford to pay per month is $300. The bank is offering a 5.9% loan. What would need to be the length of his loan so that he can stay within his budget? So sometimes when we're picking out a loan, we got to think about, well, how much can I afford a month? What's the max I can afford? And it looks like for this person, for Claude, it's $300. So based on what he can afford, and based on what the percentage rate, the annual percentage rate that the bank is offering, that determines how long he has to pay on that loan. So sometimes we start off with how much we can afford, and then we figure out our loan length later. And in order to do that, we got to use our length of a loan formula, which is this right here. Basically, if you wanted to try to work through it, they just took our monthly payment formula and they solve for T. So we'll just say a little magic happens and then we get to this formula here. So let's go ahead and break it down on the next slide. Loan length formula. The M is still the same. That's my monthly payment. So how much I am willing to pay. So in that last example, it said that Claude was willing to pay $300 per month. P is still my principal, how much I'm asking to borrow or loan from the bank. R is my interest rate. And T, what I'm trying to solve for, is my time in years. What's that length of the loan going to be? Something a little bit different about this formula, we see this ln in there. Ln is a button on your calculator. It stands for natural logarithm. If you are looking on your calculator, that button on the yellow calculators is the third button down on the left side. So it goes the second button, it says log, and then there's one that says ln. That's that natural log button. So you have to find that on your calculator. If you can't find it, ask somebody around you to help you. Again, when you're plugging this into your calculator, just like the monthly payment formula, you have to make sure to put the entire numerator in parentheses, as well as the entire denominator in your parentheses. So let's go ahead and do an example where we are using this formula. So same example as before. This Claude guy is borrowing $25,000. He wants to pay $300 a month at 5.9% interest rate. How long does the loan have to be? What's the length of his loan? Whenever we see length of his loan, we know we got to use the length of a loan formula. So let's just plug things in. So time, the length of my loan, what I'm trying to solve for, is equal to the natural log of m over p. Well, m is my monthly payments. So it says Claude wants to pay $300 a month, so that's m. So I get 300 over p, which is how much he wants to pay, or how much the loan is, the principal, which is $25,000. Close my parentheses, says minus, parentheses, just copying straight from my formula, natural log of, again, my monthly payments, which is $300, over the principal, which is $25,000, minus, says my rate, so my percent as a decimal, so 0.059 over 12, and says to close with parentheses, parentheses, all divided by 12 times the natural log of 1 plus my rate, which is 0.059, again over 12. Before I plug this in my calculator, once I've written everything out, I'm going to go ahead and add an extra set of parentheses around my numerator and around my denominator. Notice at the end of the numerator, there's 3 parentheses that you have to put in. It's important that you put all of them in, otherwise you're not going to get the correct answer. At this point, I'd make sure to pause the video. I would try plugging this in, because that's half the battle, right? And what you should get, after you've paused it and you've tried this problem, you should have gotten 8.96. Time is always in years, so we're going to say years. For time on these problems, let's say we always go to 2 decimal places. So we're all on the same page. Alright, hopefully you got the same thing as me. If not, try plugging it into your calculator again, making sure that yours looks the exact same as mine in terms of parentheses. So, one last problem. I would pause the video. I'd try this on your own before you check what I did here. So, if you're coming back to us, now it says that what happens if he can afford $50 more a month, referring to Claude from the last example. So in the last example, it said that Claude was willing to pay, based on his budget, $300 a month. Well, now it says he thinks now he can afford $50 more, so he can afford not $300, but $350 a month. So M is going to be $350. So again, everything else is the exact same. And from the last problem, just M is going to change to $350. So let's go ahead and plug that in. Still trying to find the length of the loan, so I use my length of my loan formula, which is natural log of, instead of 300, I have 350 over 25,000 minus, says parentheses, natural log of, Again, my monthly payments, which is $350 over my principal, which is $25,000, minus my rate, which is still that 5.9%, so 0.059 as a decimal, over 12, close my parentheses, all divided by 12 times the natural log of 1 plus my rate over 12. Parentheses. Again, I would put the entire numerator in parentheses, my entire denominator in parentheses. One thing to be careful of, depending on your handwriting, I've seen this before with the natural log. Some people mistake that L with a 1, so they have 121N and they're not sure where that N came from. Just be careful. Sometimes I'll write natural log with kind of a cursive L instead, just to keep those straight. But if you have good handwriting, then you won't have to worry about it. But anyways, if you plug this into your calculator, your time should be 7.35 years. Which should make sense, right? If he's paying more a month and all the interest rates are the same, the amount he's loaning is the same, if he's paying more, his time to pay off the loan should be less than if he were paying less. Right? When he only paid $300 a month, it would take him close to 9 years, whereas if he's paying $350 a month, it's almost 7.5 years. So always the more you pay, the faster you can pay it off, which is hopefully intuitive or obvious to us. Hopefully the lesson went okay. As always, email me if you have any questions. You can go ahead and now show your completed note packet to the sub, and she will get you the worksheet. As always, the answer keys, the odds are posted in the back of the room. Feel free to take a look at those. Have a great rest of your day. Get your worksheet done in class.